In this video, we're going to talk about ionic bonds. Atoms form bonds with other atoms to minimize their potential energies. Almost all matter is made of compounds, not unbound atoms. Nature has a tendency to minimize the energy of any system, including atoms. So the bond energy is the amount of energy required to break a chemical bond, or put another way, it is the amount of energy minimization that occurs when two atoms form a bond. In ionic bonds, these result from the electrostatic interaction between oppositely charged ions that form when electrons are transferred between atoms. So, if you have two negatively charged particles, they are going to repel each other. But what happens in ionic bonds is that there is a transfer of energy and there is an attraction between oppositely charged particles or ions. Generally, you get a positive charge on a metal atom and a negative charge on a non-metal atom. Metal atoms are going to lose an electron and therefore become positively charged, losing a negative charge. And nonmetals are going to gain an electron and they are going to become negatively charged. The electrostatic potential or the electrostatic attraction is described by something called Coulomb's law. Coulomb's law states that the energy is going to be equal to a constant times the charges divided by the distance between the ions, or what is known as the bond length. Therefore, when R is very, very big, your E is going to be nearly zero. So when the distance is big, R, E is near zero. And when R is small, E is going to be negative because you have a positive and a negative charge, so it's always going to be negative. So when distance is small, E is negative. Energy is lower when ions come together. Energy is going to be coming down as the distance gets smaller. And that's the idea, is to minimize that energy level so that it is more stable. Now, ions are separated out, but will start to interact, and like charges are going to repel each other, but positive and negatives are going to start to attract each other. And when that happens, things will start pulling toward each other and pairing up. And you'll get negative and positives that start to interact with each other. Now, this positive and negative then is going to still interact with other things around it on other sides of it. It's not just going to be a pairing up. It actually is going to form a 3D structure. And when it forms this 3D structure, this is called a crystal, ionic crystal or ionic lattice. This is a lattice structure. Now, these are regular ordered arrangements of cations and anions. And the change in energy that occurs upon formation of this ionic solid crystal from its component ions in the gas phase is called the lattice energy. The lattice energy is the amount of energy you'd have to add to separate 1 mole of the ionic solid into its ions. And the lattice energy is defined, or is given the equation that we've seen before. Right? Or Coulomb's law. So the lattice energy depends on both the charges of the atoms or ions, as well as the distance or the bond energy between them, the bond length between them. So the greater the charge in magnitude, the greater the lattice energy. So let's look at that. All right, so let's look at magnesium oxide here. We have magnesium if we draw structure, and we have oxygen. And so these are going to form here, and we get magnesium 2 plus with oxygen 2 minus. Okay, so that is our atomic structure here. And we can see that the lattice energy of this, if we look at our table in our textbook, is going to be 3,795 kilojoules per mole. If we look at sodium fluoride, we have sodium fluoride. The sodium is going to donate its electron. We have sodium plus and fluoride minus, and if we look that up, it's 910 kilojoules per mole. Now, sodium fluoride has a much smaller lattice energy than magnesium oxide. And why is that? Well, if we look at the lattice energy, we have KQ1, Q2 over R. Well, their charges are different. Magnesium is 2 plus and oxygen is 2 minus. So this is 2 plus and 2 minus. Down here, this is 1 and 1. And so we would expect that the lattice energy would be about 4 times greater, right? So the lattice energy is actually 4K over R. This is K over R. So the lattice energy should be 4 times greater. And if you look at this, 9, 10 times 4, we're going to get about 4 times greater. So just the charges are going to, so the bigger the charge, the greater the lattice energy. Now, the charge isn't the only thing that matters. It also, the distance between the ions plays a role, but it's smaller than the effect of charge on the lattice energy. So charge plays the biggest role, but also the distance plays another role. So if we look at these, so here we're looking at lithium fluoride, sodium fluoride, potassium fluoride. They are all +1, -1 charges. The difference is that we are all in the same group of 1A, but we're moving down that group, which means at each level we're adding on an electron shell, and the electrons are getting farther away from the nucleus. That means that you're going to have a bigger ion, right? It's going to be big, smaller, smaller. If we look at Coulomb's law, and the charges are all the same, but the distance is big. As the distance gets bigger, lattice energy goes down toward 0, right? Remember, we have a positive and negative. So as the radius gets bigger, the lattice energy is going to get closer to 0. We're going to have a smaller lattice energy. There's going to be less of a pull between the ions because they're going to be farther away from each other. So the lattice energy decreases in magnitude as ionic size increases from lithium to potassium, which all have the same charge. So the key takeaways from this are that ionic bonds form between metal cations and non-metal anions, and it's a transfer of electrons. Ionic bonds form a crystal lattice structure that's a three-dimensional structure of interactions between positive and negative charges. Lattice energy is determined by charge and radius according to Coulomb's law of lattice energy equaling K times Q1 times Q2 divided by R. So if you increase the charge on the ions, you're going to increase the lattice energy. If you increase the radius or the distance between the bond due to adding additional energy levels, and you have an increased size in the ion, then you're going to decrease the lattice energy.